All right. So hopefully you saw the exam is up. I just need it in by 11:59 on Friday night, so I can grade it over the weekend. Um, One thing that is different about this exam than my usual exams, and mostly it's because I didn't remind you when we were going through the slides, is I did not put a conversion question on this one. That'll probably be the last time, but you usually my exams have a number where you can, some question where you convert between, binary and hexadecimal or something like that. Because I hadn't reminded you that that would be on there, I didn't put that on there. So you should still know how to do that stuff, but figure I'd want to surprise you. But other than that, it's pulled from what we talked about in class, 10 questions, short answer, the usual. All right. Questions about the exam at all? Good there. Okie dokie. So let's sus. I wonder if there's going to be a question about time delta time on there, since this happened to be the last slide that that I stopped on. Yeah, hint, hint. I suppose. All right. So last time we were talking about uh, kind of programmatically representing our dungeon, similar to what we did last semester. So we're going to have a series of kind of data structures under the hood where a room links to some other rooms and things like that, like we wrote last time. And then what we're going to do is we're going to lay our Unity user experience on top of that. So whatever room our player is currently in, programmatically, the room we're standing in should look that way with the correct exits and that kind of stuff. Okay. So let's go back to our code and see where we left off there. There was no assignment for today, right? Okay. And I probably, well, let's see where we get to. I'm leaning against giving you one for Friday so you have extra time to study and work on your exam. So that means you should have good classroom participation today. or, or there will be punishment. I also could be anti doing any extra grading this week. So you got the two sides of that story too. Um, just like you don't want any homework, I don't want to grade it. So we'll see how it goes. All right. So we this is our player class. We started writing a dungeon last time. So we said a dungeon is going to have a name. A dungeon will have a room that is a start room. So whatever room this dungeon starts at, that's going to be where it begins. We kind of drew our picture here for our dungeon. So in our case, the start room would be R1. All right. So like up here, we create an instance of dungeon. Give it the name, whatever you want. We called it, the cross. We would set that dungeon start room. This is after we've initialized all of our rooms. So we're going to create programmatic instances of our rooms here, then create an instance of our dungeon, set the start room for the dungeon, and then start adding exits to those rooms so that they link to the correct places. All right. This is all happening in code under the hood. This doesn't, other than finding the right place to put this inside of our various scripts and stuff like that, this has nothing to do with what we see visually on the screen yet. All right. So let's get some of these guys in here. I'm going to steal some of this code. Now, let's ask the question, who needs to know about our dungeon at any point in time if you think about our various scripts that we have available? So if I open it up here, where might, well, let me just ask the generic question first. Who needs to know about the current state of the dungeon. Good. Okay. Dungeon controller could. Now, dungeon controller is something that lives specifically in one room, right? So dungeon controller, when we create a room, dungeon controller is a script. I think we attached it to a, we have a game object here, and we attached our dungeon controller script to this guy. Now, as we've been writing this so far, when we go to the east or west or whatever, a brand new room is created, right? That has then a brand new dungeon controller that has a, brand new exits to turn on and off and things like that. Okay, so if we created our instance of our dungeon inside of the dungeon controller, we would get a brand new pointer to our dungeon every single time a room launches, right? All right. Probably not what we're looking at. Do we have another level up? Because every room we go into, as we're walking around our dungeon, there's only one programmatic dungeon, right? We have a single instance of dungeon that has a single instance of all of our rooms in it that has all those rooms linked to each other. So do we have any place in our code that is accessible from everywhere inside of our game? Good. Singleton. All right, so whole purpose of a singleton, not that this won't be on the test either, but the whole purpose of the singleton is it's the idea that it's a good idea to keep things that need to be shared among a bunch of places, like in our situation here, inside of a single place that's accessible to all. And the kind of the secondary part of what we just said is we also only want our dungeon to exist once, right? We don't want to create a new instance of our entire dungeon every single time we launch a room. All right, so we have a singleton in here, and we called it my singleton, right? All right. Now, right now we have a couple of stuff in here that we've built for previous versions of our assignment or whatever. So what I'm going to do is I'm going to create a function. Let's call this guy generate dungeon. All right. And this guy will be static. All right. So what we're going to do in this case is we're going to put basically our code in here that makes our dungeon programmatically match up to what we've designed here. All right. Now we already have rooms. A room, when we build a room, it just has a name, so we're good there for the moment. So we're going to start off by pasting in our rooms. So these guys all exist. These are just local variables inside of our inside of this function. Need a more convenient place to put that. I wish they could let you side dock that. All right. So, back to our singleton. So we have our rooms. Oh, notice the copy and pasting thing. So I think I've maybe mentioned this before. Sometimes if you're taking code from another place, internet, something like that, and you paste it in, you'll sometimes get weird behaviors. And it's because like the double quotes here don't match the actual double quote. It's a different ASCII value. So that's why it's screaming about that. It doesn't know what this looks like. So a good thing you could do is copy one of those, search for it, and replace it with the normal one, and then copy the closing one, which is actually a different value, and replace all of those. Chances are it's only going to be in those couple of spots where you pasted stuff in. So even though they look like the same double quotes, they're actually a different double quote. Whatever, just rule of thumb, that sometimes can happen. And if you're getting weird behaviors and you keep staring at it and you don't know why, maybe look towards something like that. Did a value get copied in as a different ASCII value or something, and you just need to make it as if you typed it. All right. So these are just local variables because we don't need access to those rooms by variable name outside of this. This is just local in here. All right, so now we're going to go out. We're going to get our dungeon. And we'll set that dungeon off with the right name, and then set that dungeon's start room to R1. Now, the dungeon itself, though, does need to be accessible outside of this function, right? We probably want to have the dungeon accessible from our singleton external to our singleton, which means we need to move this variable and I'm going to call this guy the dungeon. And then we'll give the dungeon a value here. And as usual, I like to be explicit. So the dungeon is a static variable that lives in the my singleton class. So we call static variables by using the class name in which it was defined. So my singleton dot the dungeon is equal to this new dungeon. Even though we could have just said the dungeon here. And that would work just fine. The reason being is the dungeon is a static member inside of my singleton, and we are currently inside of a function that has a static context inside of the same class. So anything we just write in here is presumed to have my singleton dot in front of it. So this is not required, but I like to be explicit with it. And technically under the hood, depending on what the compiler does, it could actually be quicker. Because we're not asking it to search for that variable, to resolve that variable. If it were, it would check here first and see, do we have a variable named the dungeon here? If not, it would bounce up to the next scope and look for that variable there. All right, so we've set the start room for our dungeon. Now we want to start connecting up our rooms. And that's kind of this next part where we have a bunch of exits. And so R1 knows about an exit leading in a certain direction to another place. All right, so we can handle this a couple different ways. We can have an exit object where an exit object has a direction and a pointer in a certain direction. So I can do something like, let's do it right before this. So we can have the exit class, and maybe an exit class has a direction and it has a destination room, something along those lines. We might find it helpful to maybe have some other information in here, but let's kind of organically let it grow into that. So we're going to have these two pieces of information. So let's go back and get that into our project. So last class, we created two folders. We had a mono behavior folder and a normal class folder. And it was brought up to me at the end of class that I originally had, well, not originally, I still have my normal class script. I have player inside of there when player is actually a mono behavior as we have it currently written. So let's get him moved into the mono behavior scripts folder. All right. We probably could have handled that with, so we're going to say I did that on purpose, where we probably don't want to have a script just named player like that. Maybe the more appropriate name would have been like player controller. Controllers tend to be mono behaviors because they're controlling game objects on our screen, something like that. So just not a programming thing, just a naming convention thing. All right, so we're gonna go into our normal class folder. We're going to create a C# script, and we'll call this guy an exit. And we'll go ahead and open that guy inside of Visual Studio. And we will say, you are not an actual mono behavior. You're going to be a class that we are going to programmatically keep track of exits and stuff in. Okay, which means you don't get the start function, you don't get the update function, all those things. Okay, now we've decided that for a exit, we're going to have a direction and we're going to have a destination. So now a direction is probably going to be a string. So we'll have a private string direction. And then we're going to have a private, the destination would be a pointer to a room. So private room, I'll call this destination room. All right, when we create an exit, we could make the decision. We could say, well, do we want to create an exit with both the direction and the destination? Do we want to create an exit with just a direction and then add the destination later? Probably we could do it all in the constructor. So we'll say public exit. This guy will take in a string direction and it'll take in a room destination room. And we'll say this dot direction is equal to direction. This dot destination room is equal to destination room. So that'll hook those things up. All right, and we'll come back and add some abilities to this as we need them. So let's go back to our plan here. We decided, okay, well, we need to add a bunch of exits to our room. So the way we've written it here is that a room has a function called add exit. Now, should this be a static function or a non-static function as I have it written here? The way I'm using it, what does that tell you about the type of function add exit should be? Go ahead. Non-static. How do you know? Yep, I'm calling it with an instance. So R1 is an instance of room. It's not the class name itself. It's one of my many rooms here, and I'm using an instance to call that add exit function so we can add an exit to that particular room. All right, and our add exit takes in a string and it takes in a room. And then inside of that, we probably want to create an instance of our exit and add it to that particular room. All right, so let's go into our room class. And we're just going to follow our, follow the yellow brick road. So we decided we are going to have a public. It's not going to return anything because we're adding an exit. You could always return a Boolean if you want to say the exit was successfully added or something. If you wanted to have some error checking to make sure they don't put in an exit with a direction that doesn't exist. Like I want to add a exit in the direction of LOL. Leading to something else, but we'll just keep it as relatively clean as possible and just assume we'll never make errors. It's obviously excellent programming practice, but let's streamline it. So we're gonna just have it return void. And what did we call it? We called it add exit. And this guy is gonna take in a string direction and a room, destination room. All right. Now, we don't actually have to store this in a variable here if we didn't want to, but I'm going to go ahead and put it in a variable. Then we'll decide where to actually place that variable. So I'm going to go ahead and create an exit. E is equal to a new exit, and I'm going to pass it the direction, and I'll pass it the destination room. Now, remember, we just wrote this class called exit that has a constructor that's expecting me to give it a direction, and it's expecting it to give it a destination room. So here is me taking advantage of that constructor right here. Make sense? All right, so now an exit exists. Now I got to kind of let this room know about its exits. So when we add an exit to a room needs to put that in its like collection of exits, so we know what's available. So somewhere up here we need to have a collection of exits. Now we're already kind of representing this, so we kind of see, you know, at the beginning of class today I mentioned that we're kind of taking two different approaches. Up to this point, this term, we've been working a lot with what Unity looks like, you know, making our stuff work with collisions and all that crap. Last semester and very early on in this semester, well, really last semester is when we wrote this logic, you know, we created the code-based representation of our dungeon. Now we're going to sandwich those guys together so we keep track of the current state of our dungeon in code. And then our user interface depicts that for us in a awesome way instead of a text-based way like we would have had last semester. All right, and we're already sort of representing that from a previous assignment here, where with these things here, we were not actually dealing with the behind the scenes current state of the dungeon there. Instead, we were saying, look, every room has up to 4 doors. Forget about where those doors might lead and instances of rooms or any of that stuff. Just if I'm standing in this room, I'm going to look around and find out what doors can I walk through. Visually, what doors can I walk through? So we can have potentially up to 4 doors. And then we can, you know, because we can have as many as 4 doors, but potentially fewer doors than that, we have to choose the right data structure for this. Just so we don't have to introduce something else yet. We actually sort of kind of have in Java, I think we looked at, when we talked about generics, we looked at a class called ArrayList, which is actually an object-based collection where you can just add things to an array list dynamically. You don't need to predefine it as saying, hey, you have enough space for 4 of these things, yet let me keep down on a piece of paper how many things I've actually put in there. Make sense? Because if I ask the open doors what its capacity is, its capacity will be 4. But 4 does not tell me how many strings, in this case, I've actually put in there. When it's first born here, its length is 4, but it's the current stuff in it is 0. And only when I start adding doors to it do I get a start filling it up. So that's why we're using 2 different variables here to kind of keep track of the state of this collection. Got to be able to hold all my possible exits, but then I got to keep track of how much stuff I actually put in there. All right. So we were using this for the visual side of things. So we're going to do something very similar for our code-based side of things, and then we'll clean this up later on if that ends up making sense. So we're going to say private, we want a exit array, so a collection of exits. And we'll call this guy the exits, and he's going to be a new array of exits. And we're just arbitrarily, mostly because we've designed our room to only have the possibility of 4 exits, going to say the most number of exits we'll ever allow in a room is 4. You can certainly decide that your dungeon has up and down exits. Since we're dealing in 3-dimensional space here, nothing keeps you from like climbing up a ladder into the next room, but that's not the way we've written it. And we're getting to the kind of the maximum level of creativity that I can do with designing a dungeon. I'm sure many of you are significantly more artistically gifted than I am, but what I've done here is pretty great for me. I can only draw Teenage Mutant Ninja Turtles. Seriously, I can't draw worth anything, but I can draw those.
Find an asset for one of those player.
Oh, for the Ninja Turtle? Actually, it was kind of I don't even know how it started, but years, and I've been here since 2006. So, and every year we would have, we have this faculty retreat thing where all the faculty get together right before semester starts to, I guess, get us, you know, into a frenzy, excited about the semester starting. And it used to just be our campus here because Ann Arbor wasn't part of us at that point in time. And for the first many years, we were meeting up at Blue Harbor up in Sheboygan, which was great because they have a water park. Love water parks. But anyways, each year I would give Pastor Smith a hand-drawn Ninja Turtle. And I think he's kept them. They're in his office. I haven't given him one the last many years. I know at some point in time it fell off, but I think he's probably has at least 6 or 7 of those. That's true. What I should do is I should do a competition, have me draw one, and then ask AI to generate a hand-drawn Ninja Turtle and see, and then give it to him, let him choose which is better, and hope he chooses correctly. Otherwise, we won't be friends anymore. I'd like to say I knew him when he had more hair, but I didn't. Him and I have been in competition for a while. What was I doing? Oh, okay. So no, you don't want that. It's important crap. All right. So we have our collection of exits. We haven't put any exits in there yet. So we're going to go ahead and keep track of how many exits we have put in there. So we'll have a private int, how many exits, and we'll start that guy off at 0. We might go back and modify this guy later on, since we'll probably be reading about our number of doors and stuff. We'll probably be using our number of exits for that. But rather than break anything at this exact moment, I'm just going to leave that in there. But effectively, we're solving the same problem here. We're just storing things in terms of exit objects rather than as strings leading in directions. Okay. So for a room, we have the ability to add an exit. So we built an exit here, and then we want to go ahead and add that exit. So we'll say this dot the exits at bucket. Well, where are we going to put our next exit? The very first exit we add should go at bucket 0. The next exit should go at bucket 1, bucket 2, bucket 3, so on and so forth. We happen to have a variable here called how many exits that started off at 0. So the very first thing is we'll add the exit we just built to bucket whatever how many exits is, which initially is 0, to our array. And then we need to make sure that we update how many exits to be 1 greater than it used to be, so that we don't keep overwriting the same exit as we add exits to our room. All right. Now, technically, as we have it written right now, add exit could be called 500 times for a room, right? We're hoping we use this thing appropriately. We don't try to add more than 4 exits. But as of right now, we could have more than 4 exits, and we would then get to an error where we walk off. It would be like an array index out of bounds error where we walk off the end of our array. So if we wanted to put a little bit of error checking in here, just as an example, we could wrap this guy with an if statement and say something like, if this dot, how many exits, is currently less than this dot the exits, is it length dot length, we'll have something like that. So as long as the number of exits we currently have is smaller than the number of the capacity of our array. So once we have 4 exits loaded in there, 4 is not less than 4, right? So we won't put a 5th. So this will say, as long as we have room for another exit, we'll go ahead and build the exit, put it in there, increment our number of exits. If we don't, we just won't do anything here, and we will give the user 0 feedback. It's like, look, if you want to add 500 exits, no problem. We'll only count the first 4. All right. All the other ones we're just going to ignore because it won't get inside this if statement. So we'll call this accurate error correction with very little user feedback. All right. So now we know how to add an exit to a room. So let's see who can now do that, because what we want to accomplish here is we want to take all of these rooms and we want to add exits to them, right? So we need to put this code in a place that has access to these variables R1, R2, R3, so on and so forth. All right, so those are all our rooms with all of the exits. All right. Now, who has access to those variables? Well, if I remember correctly, we left that inside of our singleton. So inside of generate dungeon, we have access to these local variables R1 through R6. So we'll go ahead and put in our, it actually doesn't matter if we do it before or after this code. They're all going to the same place. So if you want to build your rooms, then add the exits, then ultimately put it all into the dungeon, that's fine. The order doesn't matter. So we'll put it right there. I'm going to do the same thing we did before. Gotta copy that guy. Replace. Copy this guy. Replace. All right. So we have our rooms. We added a bunch of exits to those rooms. When we add an exit, we just tell it about a string and then a pointer to a room, which is compatible with the function we wrote inside of room right here. Add exit expects from me a string for the direction and then a room pointer for our destination room. Now remember, in Java and C#, objects are always pointers. That's why we don't have a specific syntax for it. We don't use the little asterisk like we did in C++. But destination room is, if we were to just print that guy out, he would be a memory address. All right, this is a pointer to where you can find R1 inside of memory. And that's important when you look at this, where you notice that several rooms, so let's see, where R3 is involved in this exit, it's also involved in this exit, as well as this exit, as well as this exit. We certainly don't want to be handing these guys full-fledged heavy rooms, as we're saying, you have a door that leads here. Instead, we're saying, hey, all four of you guys lead to that same room where I've told you about the memory address where you can find that guy. So we're trying to keep this as lightweight as possible, and we can generally say that always makes sense in computer programming, which is why Java and C# default the behavior for objects to be pointers, as opposed to C++, where we can deal with stuff as non-pointers if we want to, and we have to use the special syntax for pointers. All right, in Java and C#, if we actually want there to be a duplicate of an object, there are some built-in functions inside of generic object to like clone an object, where it takes the memory address of an object, duplicates it, and puts it in a different memory address. So now you have two like objects, but they are distinct objects at that point. So if you did run into a situation where that was something you wanted to accomplish for whatever problem you're solving, languages like Java and C# have a tool for accomplishing that. But that will be far rarer than having it exist as a pointer, which is why that's the default behavior in more modern languages. All right, so we've added all these exits to these rooms. Then we went ahead and we built our instance of our dungeon and told our dungeon where the start room is. So if you consider this, all our dungeon knows about is one room, right? But through that one room, we have access to all the other rooms. Make sense? So technically you can say, well, yeah, my dungeon is only holding on to a single room, the start room, but that guy has hanging off of it, at the very least, mechanisms to get to all the other rooms. Okay, so you can kind of think of it as like a, I don't know, one of those arts and crafty things with a bunch of stuff dangling off of it. All right. So now inside of my singleton, we have our dungeon, and somewhere we need to tell it to generate our dungeon. Now, we only want to generate our dungeon one time. Our dungeon should only exist one time. That's why we put it inside of our singleton here, but we haven't actually called it to generate that dungeon. So we can make a couple of choices here. One thing we can do, I would call this kind of probably the best solution, but somewhat of a cheating solution for this thought experiment. We could just say, well, can't we just, when we first define our dungeon, just say that this guy is equal to my singleton.generate dungeon? Sorry, I need to, well, actually, I wrote this away where we will have a problem. So this is good. All right. So I know this guy generates the dungeon, but right now he doesn't return anything. Instead, he just comes in here and, builds our dungeon in place, but it doesn't return any value because he's setting that global dungeon equal to something. So that means this guy never actually returns a value. So that code right there does not boil down to a specific object. Therefore, I can't set this variable equal to that object. Now, we could do something like, okay, well, somebody's got to call generate dungeon. Now, I could come in here and say, well, this guy's going to return a dungeon instead of that. And I'll just make a local variable for my dungeon here. And then I'll just return that variable up to there. We can do that. We probably will do that. But as a thought experiment, we can say, well, I only want my dungeon to exist one time. Somebody, some part of my program has to be the one who's going to call generate dungeon. And then we need to make sure that that part of my program is not able to call generate dungeon again. Make sense? Because we don't want to generate it multiple times. So if we go down that path of protecting it rather than taking, let's say the shortcut here, what we might do is we might say, okay, well, what exists in every single room? Well, we did create something called our dungeon controller here. All right. And our dungeon controller, he's the guy who kind of decides what doors show up, what doors don't show up, things like that. Right. Now, since this guy is a mono behavior, we know that every single time we launch a room in our dungeon, this guy will get called because we've attached our dungeon controller to our dungeon controller game object right here that lives in every single one of our scenes, assuming we only ever have a scene that is a room. And he has our script, dungeon controller script attached to it. So every single time a room is loaded, this guy's start function and his other functions will then get called. So inside of this start function, we just kind of up here, we can say something like, should I generate the dungeon? Let me say, is this the first room and should I generate the dungeon? So we need to be able to ask that question. Because ultimately generating the dungeon is going to say my singleton dot generate dungeon. That's the code we wrote to generate the dungeon, right? And what does that code do? Inside of my singleton, if I call generate dungeon, it does all of this stuff and then ultimately sets my dungeon's value up to that and sets a start room. So after I call that function, my dungeon has been set up inside of my singleton. All right. Now, if I am inside of my dungeon controller here, how would I ask the question? Is this the first time my room has been is being called? Or similarly, has the dungeon already been created? What can we do here to create a scenario where we would be able to ask that question? How do I know right here on line 36 whether I should call that line of code or not? Any ideas? What?
Wait, this is also generating first your players.
This is every single room that ever exists will have a dungeon controller script that will call the start method. So if I walk into 1,000 rooms, this code right now will get called 1,000 times. I want to make sure it only gets called once. So how can we ask the question? How can we put the bouncer at the door of this guy and make sure he only ever gets called one time? What kind of question can I ask? This goes way back to the very beginning of 200. Remember stuff, ask questions, repetition. So I need to be able to ask the right question here to say, hey, has the dungeon already been created? If yes, don't do this. If it hasn't, do this. What question can I ask here that tells me whether or not this dungeon has been created or not? What is the value of the dungeon before generate dungeon ever gets called? Right now it has a default value. Anybody know what that default value likely is? It's kind of a hint here on the screen anyways. Go ahead. Yeah, it's null. But I've also mentioned you should never rely on a default value, right? All right. So when we first create our dungeon, our variable for it, we'll go ahead and just set it equal to null and say, look, this guy does not have a value yet. Now we could always do this with a second variable too. We could have a Boolean variable that is called like, has dungeon been created, set it equal to false. And as long as that's false, we'll create the dungeon. And then as soon as we create the dungeon the first time, we'll flip it to true. Dungeon has been created. Don't do it again. And then write our if statement with that in mind. Or we can just check, hey, what's the value of dungeon currently? If it's still equal to null, nobody's generated it, right? If it's equal to something other than null, that guy already has a memory address somewhere. Let's not break it. Let's not redo it. All right. So then we can come in here and say, if my singleton dot the dungeon is not equal to null, then we'll call generate dungeon. So even though we're asking this question every single time a room is born, we will only get inside this if statement the very first time we ever have the opportunity of generating a dungeon. All right, so now what I'm telling you is we could have avoided this by doing it all inside the singleton, sort of kind of a shortcut. But frankly, I think this is, at least from an education perspective, the better way of doing it because it gives us the opportunity to think about whether or not we should be asking, building the dungeon out right here rather than just relying on it only getting called once when that singleton first comes into existence. Okay, because something we never see is how a singleton even exists. Because we've just written this class called my singleton. I filled it up with a bunch of static stuff, right? So if we have a class called my singleton filled up with a bunch of static stuff, the only way we can call that stuff is with the class name, not an instance of the class, right? Which means we're never actually creating an instance of my singleton. How does my singleton even exist then? So we're kind of reliant behind the hood of Unity's initialization process where it goes through and knows about all the classes so that when you have a script that wants to create an instance of room or something like that, it can do it. Along with that comes its access to my singleton. And it only exists one time. And well, actually, you don't even need to think about the class only existing one time because the class could exist more than one time because we could have this guy mixed it up with static and non-static stuff if we want. But since the dungeon is a static variable, we know that guy will only ever exist one time. All right. So that variable comes into existence when our game first launches because my singleton is part of this project. Even though we never actually told it, it's like, hey, you need to remember this class called my singleton. All right. So anything we put in here that kind of automatically gets initialized might be sort of kind of easy to forget that it's happening. Even though if we think about it, I could change this guy to return a dungeon, for example. I could then set this equal to my singleton.generate dungeon. And then in here, I could just say dungeon, the dungeon. I can name it whatever I want, but we'll call it the dungeon in here. Set it up, set the start room, and then ultimately we'll return the dungeon. And in this case, the dungeon, even though it has the same variable name as this guy up here, variables are resolved through their most local definition. And the most local definition of the dungeon right here is this guy that we brought into existence right here. So in terms of scopes we have access to, currently there are two variables both named the dungeon. And right here, we're going to say, well, which one are you? It's the one, when I resolve that, it's the most local definition of the dungeon, which is this guy right here. So I will return this as a result of calling generate dungeon. This guy is now returning a dungeon object. I will take the dungeon object that he returns and I'll set it equal to the dungeon. So that's something that you could do to write this, and then you would get your dungeon created exactly one time. Now, if you're thinking about kind of optimization around this, this is faster. It's going to happen one time. We let Unity take advantage of the thing like, oh, okay, you have a bunch of static variables. We'll go ahead and set this guy up. No problem. But it's a little bit of out of sight, out of mind. And the reason why it actually is faster to do this is, let's assume that while playing our game, we bring 50 rooms into existence over time. That means 50 different times we will be asking this question. And 49 of those times, we happen to know that it would be a waste of time, right? Because 49 of those times, we will ask this question and the dungeon is equal to something other than, actually, sorry, we wrote this incorrectly. So as long as the dungeon is currently equal to null, we want to create it. As soon as it's not equal to null, we don't want it to create anymore. So as of right now, the very first time we ask this question, we'll get in here and we'll set the dungeon equal to something. But from that point forward, we're asking this question 49 more times, knowing the answer will be false every single time. Kind of a waste of time, right? Think about like a 2-year-old who asks the same question over and over and over and over again. That takes time. So we probably would not do this here for, call it good programming practice, and just rely on Unity letting that guy get created one time. Right here. So we had to update our generate dungeon to return a dungeon object. All right, questions about that? All right, so on Friday, hopefully we'll finish linking these two things together so that we can start moving through our dungeon, where the rooms, the exits, no longer randomly generate. Now they match up to what it should be based on our design of our cross dungeon. Make some sense? All right, I will see everybody on Friday. And make sure you, I gave you 2 hours, I think, for the exam, but it's designed to take, call it 50 minutes. So it shouldn't be a time pressure thing. Make sure you've set aside time, though, to take it. So give yourself a 2-hour window. You need to complete it all in one sitting. Close book, close note, whatever, blah, blah, blah. All right, see everybody Friday.